We're going to start tonight the last portion of solving systems of equations. And those are the special cases for the systems of equations. If we recall, the solution to a system of linear equations is the point where the two lines intersect or cross. Well, two questions to consider. What happens if the two lines do not cross? And what happens if the two lines represent the same line? That's when you graph them and they are the same. What happens in those two cases? And those will be our special cases. So as we move on here, let's go ahead and look at one that will have no solutions. And we'll do this by graphing right now. And 2x plus y equals 5, we can rewrite that as y is equal to negative 2x plus 5. And that's the first one there. And the second one here, we can rewrite that as y equals negative 2x plus 1. Please notice that these have the same slope. That means they're parallel lines. So let's take a look at the graphs of these. We'll graph the first one. We plot the y-intercept. We go up 1, 2, 3, 4, 5. Plot that point. Then we go down 2 and right 1. Down 2, right 1. Rough sketch there. Line looks like that. Other line, y-intercept is 1. We plot it. Same thing, down 2, right 1. And we take a look at those two lines. Parallel lines do not cross. This means there's no solution. There's no point where they have in common. There's no point they have in common, so there can be no solution to this system of equations. If we were to solve this by hand, let's go through that way. Again, this first one, y is equal to negative 2x plus 5. Let's use substitution into the second equation here. So I have 2x plus negative 2x plus 5, and that's supposed to equal 1. Well, 2x and negative 2x gives me 0 plus 5 equals 1. Ultimately, I get 5 equals 1. That's false. No solution. So we got something false, and that means no solution. I'll show you tomorrow what that means, or how we get no solution with the graphing calculator. I'll make sure everybody has those to practice those as well at that time. So let's take a look, move on to the next special case, and that's when there's infinitely many solutions. So as we take a look here, we'll go ahead and graph this. This first one, I get y equals 2x plus 3. The second equation, I end up with 2y equals 4x plus 6. Then I have to divide everything by 2. Y is equal to 2x plus 3. So as we notice, both of these are the same. If we were to graph them, we plot the y-intercept of 3, then we go up 2 into the right one. And we would graph them, there would be the same line. This would be a case where there would be infinitely many solutions. If we were to solve this by graphically, we would know that by the fact that there is one line. And let's talk about if maybe we were to do this by substitution, just to see it that way. Actually, let's do this one by elimination. Let's multiply the top equation by 2. Okay? That will give us negative. That's not what I want to do. I want to multiply the top by negative 2. Okay? So I get positive 4x minus 2y equals negative 6. So if we look at these, I get 0 plus 0 equals 0. I get 0 equals 0. That's true. That means there's infinitely many solutions. Okay? So that's how we'll know if we get a true statement at the end. Everything drops out and we get a true statement. There will then be infinitely many solutions. If we just summarize these graphically, there'd be one solution when they cross in one point. There'd be no solution if they are parallel. And if there was just one line, that means they're the same, there would be infinitely many solutions. So those are the graphical summary. We saw what happens when we do these by hand. We get true statements, there's infinitely many. We get a false statement, there's no solution. And I'll show you how we can determine these with a calculator tomorrow during class. Have a great evening.